Hey, this is Mr. Janes. In this video, we'll be talking about different types of three-dimensional solids, and we'll leave surface area and volume to a different video. First, let's talk about the basic components of solids. All solids are made up of vertices, edges, and faces. A face is a two-dimensional plane or surface bounded by edges. The faces on the solid to the right are shaded in red. An edge is a one-dimensional segment where two faces intersect. The edges on the solid to the right are colored in blue. A vertex is a zero-dimensional point where three or more faces intersect. The vertices in the solid to the right are colored in green. At this point, pause the video and try to determine the number of vertices, edges, and faces for both of the two solids on the paper. The first one is called a triangular prism, and the second one is called a cone. Pause the video now. The answers will be up in 3, 2, 1. As you can see, there are 6 vertices on the triangular prism, 3 on the front base and 3 on the back base. There are 9 edges, 3 on the front, 3 on the back base, and then 3 more connecting the two bases for a total of 9 edges. And there are 5 faces. We've got the one of these bases here, this front base, this back base, and also 3 more faces called lateral faces, we'll talk about those later, for a total of 5 faces. The cone is a little more tricky to sort out. On the surface, it looks like it has one vertice on the top, one edge around the base, and 2 faces, one for the base and one for, I guess, this face kind of tapering up to the vertice. But actually, all of those are in question, because according to the definition, a vertex is where 3 or more faces intersect, and this vertice up for this cone is only where one face comes together and intersects. So perhaps that's not actually a vertex. What about the edge? Well, it turns out that an edge is supposed to be a segment, and a segment is straight. This is kind of like a circle. It's curved. So maybe there aren't any edges in a cone either. What about faces? Well, faces are a two-dimensional surface bounded by edges. And so, first off, maybe this bottom base isn't really a base because it's bounded by a circle and not an edge. And even this other face, this kind of curved face that tapers up, is not a plane, right? Planes are flat surfaces. They're not curved. So actually, if we stick to our definitions of vertex, edge, and face, it turns out that cone actually has no vertices, no edges, and no faces. The reason for all this confusion is because a cone is not what we call a polyhedra. But what's a polyhedra? Let's talk about that next. So, what's the difference between a polyhedron, a platonic solid, and every other kind of solid? A polyhedron, or plural polyhedra, is a three-dimensional solid where all faces are planar or flat polygons. For example, all of the solids you see below are polyhedra because all of their faces are made of polygons. Triangles, pentagons, squares, as you can see over here with the cube. In addition, this triangular prism from above is also a polyhedra because the faces, again, are polygons. We've got a triangular face here, looks like a rectangular face here. So triangles and rectangles are polygons. Remember, a polygon is any two-dimensional closed figure with straight sides, so the sides are segments. So this triangular prism is a polyhedra. On the other hand, though, this cone right here is not a polyhedra for 2 big reasons. First up, not all of the faces are polygons. This circular base right here is not a polygon, remember? Because that circle is not made up of straight sides or segments. The second big reason that it's not a polyhedra is because not all the faces are flat or planar. This face up here, this face that tapers up to the vertex up top, is not flat, it's curved. So both because it's got a curved face and because it's got a face that's not a polygon, both ways it's not a polyhedron. A platonic solid is a type of polyhedron where all the faces are congruent, regular polygons. Now, because it's a polyhedron, all the faces are already polygons, but on top of that, a platonic solid demands that those faces are congruent, meaning they're all exactly the same, same size, same shape. They're also regular, they've got all equal angles and all equal side lengths. There are actually only 5 solids that fit this description of a platonic solid. It's the tetrahedron with 4 triangular faces, tetra meaning 4, the icosahedron with 20 triangular faces, icosa meaning 20, the dodecahedron with 12 pentagonal faces, dodeca meaning 12, the octahedron with 8 triangular faces, octa meaning 8, and the cube, also known as the hexahedron, hexa meaning 6, for 6 square faces. Notice again how in all of these platonic solids right here, all of the faces are exactly the same as all the other faces. They're all congruent. And all the side lengths and the angles of those faces are also congruent. In contrast, this triangular prism from above would not be a platonic solid. That's because not all the faces are congruent. The front face right here, this base is like a triangle, and this lateral face, the side one, looks like a rectangle. So that would not be a platonic solid, but still a polyhedra. However, we can be more specific than just calling something a polyhedra, not a polyhedra, or a platonic solid. So let's learn some vocabulary to name some more specific solids. A polyhedron with 2 parallel congruent bases is called a prism. As you can see here, we have one polygon. In this example, we've got hexagon, another hexagon here. Those 2 faces are called the bases of the prism. Notice how they're parallel. The other faces are called the lateral faces. And those are the ones that join those 2 bases together. So these, kind of around the outside, are called the lateral faces. Now, whenever we talk about a prism, we always name it by what the polygon is as the base. For example, this is a hexagonal prism. If it were a triangle, it would be a triangular prism. If it would be a square, it would be a square prism. Prisms can also be right or oblique. A right prism is where the lateral faces and the bases are perpendicular to each other or at a 90-degree angle, just like this right here. An oblique prism is when the lateral faces and the bases are not at a 90-degree angle. They're not perpendicular. They're not right. As you can see, it comes out slanted like this. That's an oblique prism. Here are a number of prisms, again named for the shape of their base. We have a triangular prism, square prism, rectangular prism, pentagonal prism, hexagonal prism, octagonal prism. You can see that there's an octagon base right here, all these lateral faces around the outside, and then another base up top right here. But what if we were to make the base a circle? Is there such thing as a circular prism? Since a circle is not a polygon, a prism is not a polyhedron, and actually we can't call it a prism. Instead, we call it a cylinder. A cylinder has 2 parallel, congruent circular bases. Just like before, we can have a right cylinder where the sides of that cylinder are perpendicular or at a right angle to the base, and an oblique cylinder where that angle is not 90 degrees, it's not a right angle, and it comes off slanted like this. Now, what would happen if we took either the prism and the cylinder, and instead of having 2 bases, we removed one of the bases and put in a vertex? What would those be called? A pyramid is a polyhedron with 1 base and 1 vertex. Here we have the base shown at the bottom of these 2 pyramids, and the vertex at the top is called the apex, right? It's almost like the point of the pyramid. Just like a prism, the other faces are called lateral faces, those faces that connect the base and the vertex. Just like a prism and just like a cylinder, we can have a right pyramid and an oblique pyramid. A right pyramid is where the vertex, or the apex, is directly above the center of the polygon below, whereas the oblique pyramid, the vertex is not above the center. It could be off the side or even not above the base in any way. Just as with prisms, pyramids are also named by their base. For example, here we have a triangular pyramid because it has a triangular base, a square pyramid with a square base, rectangular pyramid, pentagonal pyramid, hexagonal pyramid, an octagonal pyramid. Again, you can see this octagon base right here. The lateral faces all leading up to this vertex at the top, also called the apex. Octagonal base, lateral faces, apex. So, one more question. If we took a cylinder is kind of like a circular prism, right? What if we took that and made it into a pyramid? What would that look like? A pyramid with a circular base? What would that look like? Since a circle isn't a polygon, a circular pyramid wouldn't be a polyhedron. Instead, we call it a cone. It has one circular base, and just like a pyramid, the vertex is called the apex. Here we have that circular base with the vertex right here. Just like all of the other shapes we've worked so far, they can be considered right or oblique. Again, right if the center of the circle is directly below the apex, and oblique if it is not. Another way you can tell that is if the segment from the apex down to the center of the circle forms a right angle with the circular base. If it doesn't form a right angle with the circular base, it's oblique. Our last solid to discuss is one that has no bases or vertices. Is it possible to create a polyhedron with no bases or vertices? It turns out that it is not possible to create a polyhedron with no bases or vertices. This is because a polyhedron has polygon sides, and we know polygons are made up of vertices or points and edges or segments. And you can't have a polygon without any vertices, so you can't have a polyhedron without any vertices either. But would it be possible to make a solid, maybe something that's not a polyhedron, with no bases or vertices? A sphere is a solid, but not a polyhedron, with no bases or vertices. You can tell it's not a polyhedron because it has a curved surface right here. However, a sphere is the set of all points equidistant from the center, right here. Just as a circle is all the points equidistant from the center in 2 dimensions on a flat surface, a sphere are all the points equidistant from the center in 3 dimensions, making it a solid. Remember, equidistant means equal distance. So all the points on the surface of the sphere are the same distance, or the same radius, from the center point. The 2 last vocabulary terms we need to know about solids have to do with slicing or cutting a solid that we've already talked about. The 2 terms are truncated and frustum. First, when a pyramid or cone is cut by a plane, thus removing the top portion, the solid is said to be truncated. For example, here we have a cone. We subtract or remove the top portion of the cone and are left with this solid right here. We would call the solid a truncated cone. Here are 3 additional truncated, a truncated hexagonal pyramid, a truncated cone again, and a truncated square-based pyramid. All have a plane slice taken out of the top, could be at any angle. A frustum is a type of truncated solid. When a pyramid or cone is cut by a plane parallel to its base, the solid is called a frustum. So for example, we have a frustum of a pyramid and a frustum of a cone. You'll notice they are very similar to the truncated solids, and in fact, they're a type of truncated solid. The big difference is that in a truncated solid, this slice can come at any angle. It could be a steep angle like you see here in this cone, or like you see here in this square-based pyramid. But a frustum, the slice has to be parallel to the base. And so you notice it seems to have this very flat top for the cone and the pyramid, whereas a simply truncated solid could happen at any angle. Again, the frustum is parallel to the base. There are a lot of vocabulary terms when it comes to solids, so let's recap some of them before we go. A prism is a polyhedra with 2 bases connected by a number of lateral faces. A pyramid is also polyhedra with 1 base and 1 vertex called an apex. All the connecting faces are called lateral faces. A cylinder is a lot like a circular prism, and a cone is a lot like a circular pyramid, except cylinders and cones are a lot like prisms and pyramids, but because they've got circular bases, they will not be polyhedra. This ends the video on types of solids.